Hello everyone again. So let's do some practice problems from chapter 14, and I will start with the first problem. So how much heat is required to raise 2 kilogram of water from 20 Celsius to 80 Celsius? And we have the specific heat here. We know that heat is equal to mc delta T, mass, specific heat, change in temperature. So we have 2 kilogram times specific heat, which is 4186 joule per kilogram Celsius, times change in temperature. So 80 minus 20, that's going to give me 60 Celsius. Now if we do multiplication here, so we will have 2 times 4186 times 60, so that's equal to, so this is the right answer. So 502,320 joule. So this is the right answer. For problem number 2, so how much energy is released when 0.5 kilogram of steam condenses to liquid water? We know, guys, you have here the latent heat and you have the mass, so you can find the released energy in form of heat, of course, with this equation. So mass times L vapor, so that's equal to 0.5 kilogram times 2.26 times 10 to the power 6 joule per kilogram. Okay, and when you do the multiplication, you will have 0.5 times 2.2, so that's equal to 1.1. So I have simply here like 1 point, let's see, I think I multiplied 0.5 times 2.2, I need to do 2.26. So this is my mistake. We have 0.5 times 2.26, and that's equal to, so we have 1.13. So I have 1.13 times 10 to the power 6 joule, and you can see that A is the right answer. Okay, for problem 3, so for problem 3, we have 0.1 kilogram piece of copper with specific heat 385, increases in temperature by 50 Celsius. Find Q, which is the heat. So Q is equal to mass, specific heat, times change in temperature. So the mass is 0.1 kilogram times specific heat 385 joule per kilogram Celsius times 50 Celsius, and that's going to equal to, again I need to have a calculator, so we do 0.1 times 385 times 50, so that's equal to 1925. So you can see that A is the right answer. So 1925 joule. So this is the right answer. For number 4, we have 500 gram of ice at 0 Celsius melts completely. So how much energy is absorbed? Okay, so we have the latent heat for fusion, and we have the mass. So simply you can do Q is equal to mass times latent heat for fusion, and that's equal to 500 times 10 to the power minus 3 kilograms. So you need to convert to kilogram to meet the kilogram here. Okay, times 334 kilojoule over kilogram. Okay, so now just do the multiplication. And that's it. So we can do the following. So we can do 500 times 334, so that's equal to, and then we divide by 1000, so that's equal to, so that gives me 167 kilojoule, which is this answer right here that you can see right here, guys. Okay, this is the right answer. Now for number 5, another problem to practice. We have a metal pan, so we have 1 gram, specific heat 900, is heated from 25 to 100, so how much heat is absorbed? So we do always Q is equal to mass times specific heat times change in temperature. So we have the mass, which is 1 kilogram. We have the specific heat, which is 900 joule per kilogram Celsius, and we multiply that by, so 100 minus 25, so that's going to give me 75 Celsius. And we do the multiplication, so we have 1 times 900 times 75, so that's equal to, so we have 67, which is the first one, so 67,500 joule. Okay, so this is the right answer. For number 6, how much heat must be removed to cool 1.5 kilogram of water from 80 to 0? Okay, so let's see. Again, we have Q is equal to mc delta T. So we have the mass 1.5 kilogram. We have a specific heat 4,186 joule per kilogram Celsius times final temperature is 0 minus 80 Celsius. Okay, because the system like cooled down from 80 Celsius to 0. So now when we do the multiplication, we have 1.5 times 4,186 times 80, so that's going to give me 502,320. Okay, and actually the negative sign that you can see right here, it means that the system is cooling down, the system is losing heat. Okay, so the system is losing heat, so this is the right answer. For number 7, we have 0.2 kilogram piece of aluminium, specific heat, loses 18,000 joule. Okay, so what's the temperature change? Okay, again we have Q is equal to mc delta T, and we need to solve for delta T. It's equal to Q over mass times specific heat. So you have 18,000 divided by the mass, which is 0.2 kilogram, times specific heat, which is 900 joule over kilogram Celsius. and you will see that delta T, change in temperature, is equal to, again we need the calculator, refresh the calculator. So we have 18,000, sorry, we have we have 18,000 divided by 0.2, so that's equal to, and we divide the whole thing by 900, so that give me 100. Okay, so you can see this is the right answer. So which process involves the largest energy change per kilogram? A melting ice, a heating water, boiling water. Always boiling water, guys, involves like largest energy change. Okay, so keep this in mind. For number 9, the temperature of 3 kilogram of iron at specific heat increases by 20 Celsius. So find Q. Again, we use the same equation, guys. So we have Q is equal to mc delta T. So it's very good practice for you. So you have 3 kilogram times specific heat, so 450 joule per kilogram Celsius, times change in temperature. So you have 20 Celsius. And that's going to give me, I have 3 times 450 times 20, so that gives me 27,000. So you can see that this is the right answer, which is A. So you have 27,000 joule as energy. Okay, okay, so we are done with number 9. Let's move now to number 10. So a 200 gram copper block at 120 Celsius is placed in 300 gram of water at 20 Celsius. So what happens? Okay, both reach like 40 Celsius. Copper cools and water warms until equilibrium. So water cools down, no heat transfer occurs. So what do you think, guys? So for me, I think B is the right answer. So the copper is too hot and the water is cool when we have them together, or the water with the room temperature. So when we have them together as one system, so what will happen? You will see that the copper temperature will go down and the water temperature will go up until they achieve the equilibrium temperature. So B is the right answer. For 11, so which surface emits heat radiation best? Like shiny metal, matte black, white paint, smooth aluminium. Of course, matte black, guys, emits more radiation. Okay, or heat radiation. So for number 12, a pot of water boils at 100 Celsius. So the additional heat, okay, the heat that goes from the stage to the pot of water, this additional heat, like, raise its temperature, increase kinetic energy of the molecules, convert water to steam, cool the pot. What do you think, guys? Cool the pot is impossible. Increase kinetic energy of the molecules, that means increasing temperature, so that's wrong. Raise its temperature, and also this is wrong. So you can see that the right answer is convert water to steam. Okay. Number 13. Which statement about conduction? So which statement is true here? It needs a fluid. It occurs mostly in gases. It requires like direct contact. It transfers via waves. So what do you think, guys? It's conduction. That means it needs contact. So we need those two objects in contact so the heat can flow from the hotter object to the cooler object. Okay. Number 14, so heat transfer through the walls of a house is mainly by conduction, convection, radiation, reflection. So it is like a house wall. That means the inside and the inside environment and the outside environment are in touch with the wall. So what will happen here? We will have a conduction process. Okay, so we have like a hotter reservoir and a cooler reservoir, and between them there is a wall. So this is a conduction process. So A is the right answer. Metal heats faster than water because it has higher specific heat, it has lower specific heat, it absorbs less energy, it is denser. So when we think about metals, the metals like has lower specific heat. That means they have like less resistance to the to flowing heat. Okay, so the right answer here is B. So the metals has lower specific heat. However, water, for example, has higher specific heat. So I can say that metals are very good thermal conductor. Okay, so thank you very much, guys. I give you all of these solutions, and I hope you can prepare like better for the midterm exam, especially for chapter 13 and chapter 14, because we didn't cover them perfectly. So now, since you have these recordings, you can go through them and prepare for the midterm exam, and also we can start this coming week, we can start like new chapters. So I'm not going to go through chapter 13 and chapter 14 since I posted these solutions for you guys. So if you go through these recordings and these recordings for chapter 13 and 14, and if you go through the discussion questions, and if you do the blank notes, and I believe Mr. Neil did pretty good work in his channel, so he has all of the blank notes solved in his channel. So if you have all of these resources, I believe you will do pretty good in those two chapters. Adding what I'm going to post for you guys, these recordings. Okay, so yeah, thank you very much, and yeah, and see you in the session, guys. Thank you.